Hello there, welcome to a video about the Handpose feature of ml5.js. So Handpose is the feature of ml5.js that, you guessed it, it lets you recognize hands. So what does that look like? Well, right now this is a Handpose sketch running in my framework for it. And you can see that when I put my hand up, it's sort of pointing to my index finger, right? So as I move my index finger around, it's tracking it. And that's what Handpose does. That's what it's for. That's what it does. Works on both hands. There you go. You can see it's a little bit like it's not perfect, but it's pretty amazing as a thing to be able to do. So that's what Handpose is for. It's for detecting hands. In particular, it can detect a whole bunch of points on your hand, and we'll look at what those are in a second. But this is the gist of it. This is what it's for. Okay. So we want to use this. Oh goodness me! And I guess my camera just vanished for a second there. We want to use this, and so how are we going to address that? We are going to go to the ml5 website, and we're going to look at the documentation for Handpose. So let's do that. No justice, no peace. Yes, indeed. So we now know, we're experienced ml5 users. We go to the reference. And then in the reference, we scroll down. Now, Handpose is a thing that's about recognizing things in images, right? So it's in the image category. And we scroll down here, and there it is there. There's Handpose. So I'll click on that, and then we get its documentation. And so, as is traditional, because what I want more than anything is for us to get used to reading the documentation and sort of understanding what's possible from that documentation, rather than just treating it like total magic. Let's go through this documentation and think about what it is trying to tell us. So, it's the standard ml5 documentation form. So the very first thing is the name, Handpose. That means we know we're in the right place. The very next thing is an image that's telling us, in a picture, what it is that this thing can do. And you can see it's recognizing a hand. Unlike the example that I was using, where I was just tracking the tip of my index finger, you can see that what Handpose is delivering to us is a set of points on a hand. And in particular, if we kind of just look at this for a while, we can kind of glean that it's identifying the tips of all of the fingers and the thumb, the locations of all of the knuckles, the flexion points of the hand, and there's actually also one extra point at the base of the palm that's being tracked as well, which obviously could be useful. And that's kind of the key data that we can therefore expect is going to come out of Handpose that we might use to achieve things. It effectively is telling us things about the hand in the image, like in a lot more detail than just there is a hand, which may be something like an object detector would do. This is going into great depth in terms of where that hand is and how it's positioned in the image. And we can use that to do interesting things in our programs, presumably. So we get excited. We look at the image and we're excited. And that's good. Then we read the description. It's always worth reading the description. So it's a machine learning model that allows for palm detection and hand skeleton finger tracking. So that's a bit more detailed. It can detect a maximum of one hand at a time. That's really worth knowing, right? So we can't expect to hold up both of our hands and have it recognize them. That kind of puts a damper on dreams that we might have had of, like, recognizing sign language, for example, since that's a two-handed language. So that's something that we need to be aware of. Maybe slightly disappointing, but we're still playing with magic here. And also it provides 21 3D hand key points. So that's not apparent really from this image here. But the coordinates that we're going to get out are not just x and y coordinates in 2D space, they're 3D coordinates, x, y, and z, so that we get the representation of the hand in 3D as we move it forwards and backwards as well. So that's super potential. That has a lot of potential as well, right? If we want to do things in 3D. And as we can see here, it owes its existence to TensorFlow, just like pretty much everything inside ML5. So let's continue on. ML5 always provides this kind of plain JavaScript, simplest possible version of using a feature. Again, the key things for us to note when we look at this are, well, we need some kind of source of images that we can do detection on. In this case, it's a video element that's on our web page. We're going to need somewhere to store the predictions that our hand tracking is making. That's going to be an array. And then the absolutely key things we need to do are we need to create a Handpose object so that we can use that feature. And as you can see here, we're telling it to use this video. That's what it's going to be processing. And we're going to call this function when the model is loaded. Model loaded. That's not really doing anything. That's just saying that the model got loaded. This is very bare bones. And then the other thing that we're going to do, which might be new to you, might not, is rather than repeatedly call some specific method on Handpose every time that we want to recognize the hand or potential hand in our image, we can actually just listen to predictions. So when we say Handpose, which is the actual feature object itself, and we say on, and then on means we want to listen to something. This is common across many libraries and frameworks. On means I want to listen to some kind of specific event. The name of the event is predict. That's why the first thing that we see in here is predict. And what that's saying is I want to be notified whenever the predict event happens, which means that Handpose has recognized a hand and has data about it available. And so we're saying I want to know when that happens, and when it happens, I want you to call this function that I'm giving you here every time that happens. So from then on, after we've done this, Handpose will just be automatically notifying us every time it makes a prediction about hands, and so we just need to work with the results of that. So that's kind of useful as a model for us to be able to use. It's worth noticing here that this is using an arrow function. What this is saying is that there's going to be a function. It's going to be provided with a parameter called results. That's where the data is going to come in every time this gets called to tell you that there's data available. And what is it going to do with those results? It's going to assign those results into our predictions array. So every time there is some data about a hand, in this absolute simplest example, it's going to assign that into our predictions array so that we always have them available and we can do stuff with those predictions somewhere else in our program. Okay, so that just gives us the gist of how this works, but then we can continue to read through and kind of get more of a sense of how this is actually going to work. So let's take a quick look at the actual usage documentation. In the back of our mind, we're probably going to be thinking, well, the examples is probably where we're going to really get maximum information about how to really use this in some actual context. But it's always worth just looking through the usage to make sure that we know what's also just sort of additionally possible. So as with other ML5 features, there's an initialization method that we need to call to kind of bring our model into existence in our program. This one is called ml5.handpose. That's how we create one of these models. And we're going to provide it with the video that it's going to be processing. So in this case, it's suggesting that we should use video specifically, not images. So video, that could either be a video element or it could potentially be the webcam. There's some potential options that we could use to tell Handpose how to do that. A lot of these aren't really going to be relevant, or they're going to be very technical. And then there's the callback, which should be called when the model has loaded. We saw up here that all that they did with that in this example is they just use a console.log so that we know that the model has loaded. But if we want a loading screen, for example, then this is when we would know that the model's finished loading and we could move to the next stage of our program. Okay, so there's the video, the configuration options object, and the callback function. And then we get a little bit of extra information here. So there's the video. It's a little weird that it's optional, to be honest. I don't know what Handpose is supposed to do if you don't tell it what to run predictions on. Possibly you can provide that information later on. That might be why they're doing that. The options object is optional. As you can see here, they're giving us the list of possible options that we can set here. Of these, a bunch of them are like really quite technical things about how the model works. You're welcome to play with them, but generally speaking, I think I wouldn't mess around with the defaults unless I have a really specific reason to do so, just because you don't necessarily really understand what they mean, right? It doesn't mean that you shouldn't play with them or that you can't have a mess around, but they're probably set to these numbers for reasonably good reasons. The one that is worth remembering for later is this flip horizontal. And this is the question of whether when it's processing the position of a hand in some kind of input video, it should first flip the video horizontally. This is especially important if you want to have a kind of mirrored effect, so that when I lift my right hand, it looks more like, when I'm looking at a webcam output, it looks more like a mirror than like a flipped version of myself. If we want to flip the image that we're looking at, we also then need to flip the detection. So flip horizontal is what would do that. By default, it is false. Okay, so that tells us what those options are, and then there's the callback function that's saying it's a function that's called once the model is loaded. Again, that's useful if we're wanting to do some kind of loading screen. There are also these properties that we can use once we've got a handpose object. So we could say handpose.video to get access to the video element that it's processing. Handpose.config gives us access to the configuration options that were set. The model is the model itself, and model ready tells us whether or not the model is available right now. So if there's some kind of specific checking that we want to do during our program, it might be useful to check one of these particular properties. I personally haven't necessarily found a lot of use for them as yet, but that doesn't mean that you shouldn't at least know that they're available, right? Then we have the methods. These are the things that Handpose can do. There's basically two major things. One is that there's a method called predict that we can see right here, handpose.predict, and you tell it what to do prediction on, potentially, and the function to call when it gets results. So this is a one-off prediction step, right? This is saying, do one single prediction, and when you get results, call the function that I specify. So this is if we only want to detect a hand for one frame of the video, or one specific image that's being displayed on our canvas. Look, they misspelled HTML, HMTL. They were in a hurry. But you can see here that it can work with images, for example, not just with video. It can work with video. You can even give it a canvas element. So you could have a P5 canvas, and it could do hand detection on the imagery being displayed in that canvas. So there's some actual potential kind of hidden in here. Like, they don't make it as clear as they could. The diversity with which this can work with different kinds of inputs. I think it's sort of, the default is so much video, and in particular webcam input, that this stuff gets a little bit sidelined, but it's worth remembering that you might want to do this. And the key thing here is it's a single prediction, right? So this method predict gets run one time and does one prediction, and that's it, okay? And other than that, it runs in the same basic way that we saw in the other example with on. It calls the function, it gives it some results, and then you do something with the results inside the function. Not very helpful, pretty terse in terms of this little example. It's really just trying to show you some syntax, and we'll derive more meaning from the examples. Here's a really key moment though, right? And that's the output. What output comes out of these prediction steps? And this is key. So it says it gives back an array. That's important to know. That's actually pretty consistent across ml5's features. Returns an array of objects describing each detected hand, which is a bit weird when you think about it, because we know that it can only detect one hand. So it's always going to be just an array with, I guess, nothing in it if it doesn't find a hand, or a single object inside it if it does detect the one hand that it can detect. I would assume that they're doing this because in the future they may want to extend this to recognize multiple hands at the same time, and then an array would make the most sense as a thing to return. And you can imagine that then you might as well have an array from the beginning so that you don't break people's programs from the past if they were using a different kind of way of expecting only a single hand. So we need to remember it's an array. Fortunately, they also do give us a look at what that array is going to look like. It's a little bit weird because they don't give all of the information. They give some of the information. So it's like, there's some specificity here, but it's not everything about what is going to be delivered. And I don't necessarily understand why. It's actually true even in the TensorFlow source. This ends up happening to a certain extent. They don't explain everything. However, we can see that in the array there's going to be an object. We know there's just going to be one because there can only be one hand. And these are the properties that tell us about that hand. This hand in view confidence, that's how sure that Handpose is that there is actually a hand there. So 1 would mean total confidence, 0 would mean it's, I guess, certain that there's not a hand there, which would be kind of weird. There's a bounding box that tells us describes a box around where the hand is, its dimensions. It's described in a different way to what you might expect. It doesn't give us an x, y, width, and a height. Instead, it gives us a top left and a bottom right. So that's another way of describing a rectangle, right? The top left corner's coordinates and the bottom right corner's coordinates. You can see that as we've been seeing with ML5, it describes coordinates using an array. So the first thing is the x at position 0 in the array, and the second thing is the y at position 1 in the array, and same thing here. I'm guessing that's just convenient for some reason. It may even be a memory saving or a speed or efficiency trick that they're doing, because potentially using an object in that context is somehow just less efficient. I couldn't tell you. So there's the bounding box that tells us sort of the overall area where the hand is. And then we've got these two options for how to interpret the very specific hand data that we saw at the top, right? So we've got landmarks. Landmarks is just a straight up array of arrays. So there's an array, and inside it, it's got a series of coordinates. Here's one, here's another one, and then there's more. And we know that Handpose, if we were reading the documentation, can detect 21 specific coordinates on a hand. So there would be 21 of these things inside this array. Each one of those is giving us the position of, well, we don't know, right? It's giving us the position of one of the points on the hand. But you can't actually tell by looking at this which point is which. It's just all of the points in an array. The other thing that we can see, which we remember, is that these are 3D coordinates, right? So we've got the x is the first element, the y is the second element, and the z, or z, is the third element. So unlike the bounding box, we've got 3D coordinates here. So the landmark just contains an array of all of the points on the hand, and it doesn't really tell us here which point is which. So I can't tell, looking at this, which one would be the index finger, the tip of the index finger, right? So the landmarks is one way to go about this. There is also, however, an annotations property, and this is, as it says, a semantic grouping of the landmarks coordinates. So this is making some attempt to make this data actually make some sense, right? So inside annotations, we have a property called thumb, and inside thumb, we're going to have an array of all of the coordinates to do with the thumb, right? So we've got the first set of coordinates that are somewhere on the thumb, the second set of coordinates that are somewhere on the thumb. But again, in this documentation, it is obviously helpful that I can now just get the thumb-specific data. It still doesn't tell me which bit of the thumb this is. It doesn't tell me if this is the base of the thumb here, or that this is the tip of the thumb, and this is like the middle knuckle of the thumb. We still can't tell. We also can't even tell what else there is. Like, we would assume there's probably index finger, middle finger, ring finger, little finger, right? But we don't know the exact precise way that they're named. So this is pretty unhelpful. And this suggests to us that we're going to have to investigate a little bit to really find out the specifics of how this is working, which is fine. It's just that we need to know that that's an issue, and we'll work with that as we move forwards as well to really understand what's inside this data. Nonetheless, we've got the basic idea of the kind of data that's being spit out by this model. So the other thing that we've already seen now is this on method, right? So we say handpose.on, and then it's got a predict event, and we tell it the callback to call. Here's the example here. So handpose.on, I want to listen to the predict event, and I want to call this callback function when there is a prediction. And the beauty of on, as we discussed earlier, is that it's just sort of active all the time. So we don't have to continuously call predict. We just know that whenever Handpose detects something, it's going to call our callback function with the data for that detection. That's just an easier way to do continuous detection than repeatedly calling predict explicitly ourselves. We could do that as well, but this is just convenient. The callback, again, it's just going to do something with the result. So it's going to always be given a single parameter, and that's going to contain the results. And remember, the results are this array here, right? So this is the results that are going to be given to our callback each time a hand is detected. So that is a sort of more convenient way to do continuous detection. All right. So we've absorbed a lot of information. This is a perfect time, fortunately, to actually see some examples so that we can kind of return to our excitement about how this even works, and our desire to kind of see it in a little bit more context than we've been seeing so far. So again, they've got examples in regular p5.js, which would be a GitHub repository. But importantly, we can look at this in the P5 web editor, and that makes it possible for us to really kind of take a look at how this is working. So here we've got two examples. One is just doing a hand pose on a single image, which is fine, and one's doing it on a webcam, which I suspect is going to be more fun. So that's the one that I'm going to take a look at. So there we go. This, interestingly, is making me look at index.html, which is not actually what I want to look at, because I want to look, obviously, at the code. So I'm going to switch across using this little sidebar to the sketch. And I can switch this thing back across now. So here's the code. It's really not much code, but let's run it and see what it actually does. So there's me looking, well, I'm looking at myself. I paused, right? This is like the Handpose model, kind of like actually getting its stuff together. Sort of an unfortunate image of me with my eyes closed. Wish that would finish. Oh, look, and look at that. Did you see that little constellation of green dots kind of hovering around that can? That's it. That's Handpose thinking that that's a hand, right? So this is important and useful because like this is telling us that Handpose can be wrong. Like it is wrong. That is not a hand, Handpose. It's not listening to me, so it's useless. But it can misrecognize things. This is part of machine learning, right? It's a false positive, is what we would call that. But if I put a real hand in front of the camera, Handpose is like much more confident that this is a hand, and so it's doing its little thing, right? We've got a little green ellipse circle being drawn on all of the points that Handpose recognizes. Wonderful. And as I move my hand into different configurations, you can see it's struggling a little bit with certain configurations, but it's pretty incredible. It's pretty incredible at what it's doing. It's really doing a nice job of detecting all of the points on my hand as they move around. Just by way of illustration, it's not that it's recognizing like a real hand. It's not that it only works on real hands. So for example, I've got a picture of my hand here. And if I hold the picture up, it's not like it can tell a living hand from a picture of a hand or anything like that, which I think is just, it's just worth knowing. Okay. So we've got working Handpose. Let's take a quick look at this code. It's just going to be using those elements that we've already seen, right? So it's just putting them together into a slightly larger program. So we've got the variable up here to store the model in. We've got another variable to store the video feed in. That's the webcam that you're seeing me on right now. And finally, we've got a variable that's going to store the predictions in, the Handpose predictions in, so that they can be used throughout the program. And again, this is a pretty conventional structure that we see with a lot of ML5 stuff. Oh, it thinks my face is a hand. I think that's possibly kind of insulting. I'll try not to think about that. So we create a canvas. That's normal. These two lines here, we are creating a webcam to use on the web page and setting its size. Here it's a bit different to what we would maybe normally do ourselves. It's creating this capture, this video capture, this webcam here is actually, it's sort of existing. Oh, no, I take it back. So it's a bit weird, but they then hide the video down the bottom. I don't know why they've decided to do that. They've split up all of the video stuff, right? So they create the capture, resize it, and then they hide it down the bottom. That's because we only want to see the canvas. We don't want to see an HTML element with the webcam in it. So that's about getting the webcam going. Then we see that exact setup initialization method, ml5.handpose, providing it with the webcam, which is this, and providing it with a function to call when the model is ready. That's model ready. And all that is doing, as you can see, is saying model ready. That's why, again, down here in the console, we see the words model ready, because the model loaded and it was ready. And then the other key thing is this continuous hand recognition that we were talking about. So handpose.onPredict. Listen, tell me about the predict event. Every time the predict event happens, like now, pow. It's happening like over and over again. Every time that happens, it's going to call this function. It's written as an arrow function, which takes one parameter, which is the results. So Handpose will give that array of data to this function. It will come through in the results parameter. And in there, all that we're doing, as you can see, is we're assigning those results to our predictions array. Why do we do that? It's because the predictions array is a global variable. And by assigning results into that global variable, it can be seen everywhere in the program. So if we want to use the Handpose data in different places in our program. By putting that data into our predictions variable, it's then visible everywhere else, such as in draw, where it's being used in this program. And that's all that it's doing. And this is pretty typical. You don't have to do a whole bunch of stuff when you get the data. The key is to make the data available to the rest of the program all the time while the program is running. Okay, the rest of this is happening in draw, and in particular in draw key points. So draw displays an image of the webcam. That's why this is happening. And it also calls this draw key points function. And you can see that this is going through the predictions array. We know that that's an array because we looked at how the data structure worked. That's an array that contains a single object representing the hand that's being recognized, if there is data in there. So it's going through that array, but we're expecting it to only see one object because there's only one hand. It's pulling out the prediction for that hand. You could call this hand if you wanted to as well, this variable, because it's data representing a hand. And then it's going through, for that particular hand prediction, it's going through the landmarks property here, right? This is the landmarks property, and we remember that that was just one giant array of all 21 points represented on the hand, not really caring about which one is which, right? So it doesn't care which one is which. We can't tell what order these are actually being drawn in because of the way that this is written, right? So it goes through every single landmark, and as you might probably be able to tell looking at the video, it draws an ellipse at the X, Y position of each of those landmarks. That's what it is doing, right? And that's it. That's what this is doing. So it's successfully pulling out the data from Handpose and drawing these green circles at every position by going through the landmarks array, which is a property of the prediction that it's just made, and drawing the ellipses there, and that gives us this dynamic shape. It's not really doing anything. This is purely visual. But you can see what the data looks like, which is great. However, maybe we still have a little bit of unsureness about how the data is actually structured. So one thing that we could do if we still want to know a little bit more detail about what do these results look like, what specifically is in there, we could add a line to this program, right? We could say console.log results. So when this prediction happens, one of the things I want to do is I just want to print out what the results are so that I can see them in this console and I can actually inspect what they look like. So let's rerun this sketch. Should have composed my face perhaps a little better. I didn't think about that. So if I hold up my hand, oh, they're looking like something right there. There we go. So I'm going to take my hand away. So the thing, let me scroll up here. Oh, this is a disaster. I'm going to stop this. Okay, so I've stopped the program just because it was going to keep spitting out results. But here is a result. Okay, so this overall thing is the array with the results in it, and it's got one thing in it, right? At position 0, and it's an object. If I expand that object, then I see all of those pieces of, all of those properties that I saw in the documentation. Hand and view confidence was at 0.989, so it's very sure that it could see a hand. The bounding box contains the top left and bottom right position of that hand, which we can see there. So that's where it was. One of the things that we can kind of maybe see there is that it might be calculating positions relative to the center, just because it's got these negative positions here. Or it might just be that it thinks that the hand is slightly off the top left corner of the canvas. I don't actually know from looking at that which of those is true. We could experiment with it if we really wanted to know that. Then we have the landmarks array, which, as we said, contains all 21 different points. So there's the first one, for example, X, Y, and Z, 0, 1, and 2. This is all of the points of the hand. But looking at this, we can't tell what any of them actually mean. It's not actually very useful for that reason, if we want some kind of semantic understanding of that data. So really, a lot of the time, if we're wanting to do specific things with specific fingers, for example, like say what I really want is to draw a circle on the tip of my index finger and the tip of my thumb, let's say, because then I can do a pinch or something like that. That's going to be sort of annoying to do with these because I don't know which number refers to which finger and which point on which finger. So I might be more interested in the way that this annotations object works. And here it is a little bit helpful, right? We've got annotations. Inside we've got thumb, index finger, middle finger, ring finger, pinky, and palm base. That's useful because it tells us the specific property names if we're wanting to access these things, and that's good. So that's helpful. So now we've kind of drilled into this object. So we've got the hand object, and then inside it, let me close a couple of these things now. Inside it, we've got annotations, and then inside it, we know that we'll be looking at thumb and index finger. And then inside thumb and index finger, we've got four more arrays, and inside each of those arrays are actual positions. So X, Y, and Z, right? 0, 1, and 2. So there's four positions for each. And again, it doesn't tell us what those mean. So we kind of bottom out there in terms of meaning. The thing that we probably can remember from the documentation is that it's doing the finger skeleton. And if we were looking at the dots, we could see that one of them was at the base of the index finger, for example, and then there were two at the two knuckles, and then there was one at the tip. So one of these four things is the tip of the finger, which is the thing that I want. And that's true for the thumb and for the index finger. Which one is it? It's most likely you would think to be either 0 or 3, right? Depending on how they're counting. Are they counting from the base to the tip or the tip to the base? Who knows? If I were guessing, if I were doing this, I would assume that 0 is the base of the thumb and 3 is the tip of the thumb, and likewise for the index finger. But we would have to experiment to find out. It's not telling us that information. However, this tells us the path that we could get to that information, so let's make an educated guess. So I'm going to remove this console.log just because it's going to be distracting. And in here, instead of drawing the key points, I'm just going to delete this. I'm just doing this here since they've provided us with this handy little sketch. I am going to try to get a prediction. So there are different ways of doing this. I could just loop through the predictions, and maybe that's a reasonable way to do it. Or I could say if predictions.length is greater than 0, that would mean that there's something inside the predictions array right now. It's not empty. So there is a prediction for where the hand is. And so if that were true, then I could say that the current hand prediction is at predictions 0, right? Because we know that there's only one of them, and we know there's one in there, so that's where the hand would be. Now, inside that hand, if I wanted the information about the thumb, then I could say that that's inside hand.annotations, because that's where we saw that all of the actual named stuff was, hand.annotations.thumb. And that's where all of the data about the thumb is. And we know that there's 4 things in an array inside that thumb data. And I could do the same thing for the index finger. Index is hand.annotations.index, because that's the structure of that data. And now if I want to draw ellipses at those 2 points, I'm going to need the XY coordinates of the tip of the thumb and the tip of the index finger. And like I said, my suspicion is that the thumb tip data is at thumb position 3. I think it's the last thing in the thumb array. And same thing for the index tip. That's it. Index, it's at the last element in that index array that we're pulling out. Oh, and actually this was called index finger. Thumb and index finger were the 2 things inside the annotations. Each one of these contains an array of 4 elements representing the 4 kind of joints that it's depicting. And my guess is that position 0 in this array is going to be the base of the thumb and the base of the index finger, and the final one, the 4th one, which is at position 3, is going to be the tip. So then I can draw my ellipses, right? So we'll do let's do it in red because we're feeling fancy. We should always do push and pop, shouldn't we? I don't want to be a bad person. So push and pop, and then I want to draw an ellipse at these 2 positions. So I'm going to draw an ellipse at thumb tip, and we know that the X position is at 0, and we know that the Y position is at position 1. That's the way that they did it, and the Z position is in position 2. And I'll draw it as 10, 10. Sure, that's what they were doing. And same thing for the index tip. Index tip 0, index tip 1. It's sort of unfortunate that it is a little bit harder to read, right? Because this doesn't say X, this says 0, and this doesn't say Y, this says 1. That's unfortunate. That's just the way that they have formatted the data, and it's something that we have to live with because we didn't make ML5. We might have done it differently. They probably had a really good reason for doing it this way. I would trust them. So then we've kind of got this little program. Let's make sure it works. It's probably not going to work. There's me. Ooh, well, at least I don't look like totally embarrassing. There we go. I was trying to compose my face in case it did a freeze frame. You can see that I got it right. Yep, so you can see, I mean, it's not perfect. Oh, it's really not perfect. But yeah, but I'm pretty sure that this is correct. So you can see that it's drawing circles where it thinks the tip of my index finger is and where it thinks the tip of my thumb is. Yeah, and I can even bring them kind of closer together. It's almost like it's not super keen on this pinching movement. If I close my hand like this, it's better at that, right? But you can see that there's like, you have to treat it almost like a little animal that's good at certain things and not good at certain other things. It's not doing terribly. You can see it's also maybe getting confused by my face being there. And it's a bit happier there. Interesting. So the background, presumably also matters too. It's less busy against the door, so it's able to really get a pretty good read on this. Nice. So we guessed correctly, and that's this is really the process of all of this, right? Is we need to be able to leverage the very, very basic stuff about how to get these models actually operating, which is really hugely comes down to, get some kind of input, like the webcam over here. Actually create a version of this model in your program by telling it about the video. So that's the ml5.handpose method. And have some way of pulling out the data that this model can provide you with, which is this onPredict thing that we've got here, which is just always storing the results. And then you have to do something with it. And doing something with it is like obviously it's the most important step. And a huge part of that step is just being able to pull out the information that you actually want. Because it's unlikely that you just want all of the points on the hand indiscriminately. It's more likely that you want to find specific points on the hand or like specific measurements of the hand or something like that. And to do that, we had to do a little bit of extra kind of drilling and processing of that data. We made sure that there was something in the predictions array first with our if statement. Then we pulled out the specific hand prediction. We knew that this was at predictions position 0 because there's only going to be one hand there because of limitations of the library. And then we knew that we could pull out the annotated data for the thumb by going hand.annotations.thumb. So that's kind of drilling into that object that comes out of the predictions. Same thing for the index finger. And then we made this educated guess that the array inside the thumb that we just corrected, which has these 3 sets of coordinates, that the third set of coordinates would be the tip of the thumb. Same thing for the index. And then we need to remember, finally, that the xy coordinates are represented as elements 0 and 1 inside that array. And we got this thing. We can do a pinching simulator now. Pinch, pinch. Good. Okay, wow. Well, I mean, so we've done a lot in looking at that example. So let's close the example for right now. Oh yeah, I did make changes, but that's fine. So we looked at the examples and we went a long way there. Perhaps I went too far even. But we went really into how that example worked and how do we pull data out of the model once it's running. So that's good. We have a pretty good idea now of what data can come out and what we could potentially start doing with it. So what else is in the documentation? Just for completeness, kind of nothing, unfortunately. There's no demos. There's no tutorials. You could make one of these things if you wanted to. That would be nice of you. There's no model and data provenance, so we can't do some of that kind of reviewing of potential ethical, political, cultural bias, those sorts of things. And we can say thanks very much to Bomani here, who actually did the port of Handpose from TensorFlow into ml5.js. Thank you, thank you. And we can, if we want to, look at the actual source code of Handpose. But then we've completed like quite a large process, right? We've gone through the entire example. We've thought about how the data works. We've used the data for something else, and we're kind of ready to really work with Handpose at this point. The only remaining thing that I want to just very quickly do, just so that we see it in this video, is I just want to like have it in my own project in Atom, just because I think that that's useful. So let's go through that quick process. So I've got my template project here. You may have one ready somewhere else as well. This is just a standard P5 project. I'm going to go over to the AI, and I'm just going to paste it in there and rename it to Handpose. So this is just an experiment with Handpose. I'm going to drag that into my Atom over here. And in the script, I'm going to just literally paste in a framework. Oh, no, I'm not. I'm going to copy it from over here, and then I'm going to paste in, there we go, paste in a framework. This is just a slightly more sophisticated and polished version of what we already saw on the Handpose documentation and the examples. I just want us to be able to work from, so this is available in the notes, right, and in the course materials, just so that there's a slightly more sophisticated version of an example with a lot of commenting and discussion. But there's one other thing that I have to do, right, if I want to use a Handpose for literally anything. I need the script. So I need to find the script tag. I cannot remember what it is, so I'm going to go back to ml5.js.org. I'm going to go to Getting Started because I know that's where it is, and scroll down, and there's my script tag, right? So I'm going to copy that script tag there. That will point me to the latest version of ml5, the library, and I'll just paste it in right there. If I was being cool, I'd maybe put in a comment like ml5.js, like that. I just did, by the way, command / to turn that into an HTML comment. And then we're ready to go. So if I run this, this is just the example that you saw me using at the very beginning of class, I believe. It might be slightly less amazing because I may have changed it at some point. Oh God, this is just like one of the dangers of teaching anything that uses webcams. How embarrassing. Oh no, this is fine. So this, this is what it's doing. It's tracking my finger. How great. How clever am I? Yeah. Oh, I guess the only thing is this is not mirrored for me, so it's not working like a mirror, but it is working for finger tracking, and it's doing the same thing that we worked out before, which is some index finger tracking. In terms of what's actually in here, the only real difference is that it's got its little loading sequence where it tells you that it's loading, but otherwise it's the same stuff, right? We create a video capture of the webcam, we hide it, we create a new hand pose, and when that's ready, we switch to the running state. So we've got a kind of a state-based understanding of our program. First it's in a loading state, then it's in a running state. And just like the example, when there's a prediction, we put the results into our predictions array. I've got an anonymous function here written in a standard way instead of the arrow function, but it's doing the same thing. Draw just calls the appropriate function, loading if it's loading, running if it's running. Loading just says loading the model. And when it's running, we check if there are predictions. I could also do, like I did last time, if predictions.length is greater than 0. That would also be reasonable. / maybe better. Maybe I'll change that. And if there are predictions, then it goes through the predictions. And actually, this is using the loop version. As it says here, though, technically there will only be one. Like Highlander, there can only be one hand prediction. And it goes through, pulls out the hand, and highlights the hand. How does it highlight the hand? Just with that same thing that we saw. It knows that it can find the tip of the index finger at hand.annotations.indexfinger, the third element of the index finger. It's pretty naughty, right? But you just have to, you just get used to it over time. And it knows that the X is at the 0 element and the Y is at the 1 element, and it draws an ellipse at that position, right? So it's the same thing that we just did before. It's just a little bit more kind of fleshed out here. And this framework is in the notes, etc. So you can use this as a starting point if you want to. And from there, right, it's what do you want to do with this? Do you want to do some kind of pinching simulator? Like you could be like a crab, a one-handed crab, I guess. That's unfortunate. Pinch, 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 pinch. I don't know which hand is which. Do you want to ask somebody to draw a picture of a hand and see if it gets recognized? That would be kind of interesting. Like, you see it recognizing weird things as hands, like this jar up here. Why is that a hand? I couldn't tell you. Or just whatever you want, right? Like once you have this idea that you can recognize a hand and its position and configuration, it becomes like, what would you want to do with that inside of a program if you had that information? And that's where it gets super exciting, right? That's why this is fun. So that is my introduction to Handpose. In particular, reading the documentation and really getting into how does it work and how does the data work. And then from there is where you kind of bridge into doing things that you think are interesting with it. And I hope that it's exciting to you. It's certainly exciting to me. Thanks for watching. I'll see you next time.